and welcome to Math of Ms. B, Theoretical and Experimental Probability. So in the previous video, we defined and looked at the probability of simple events. And in this video, we will define the difference between experimental and theoretical probability. We're focusing on the Standard 38 SP7, specifically the part that says compare experimental and theoretical probabilities of events. So let's define our two types of probability. Theoretical probability you'll find is very similar to what we did in the previous video with simple events. It's the ratio of the number of favorable outcomes to the total number of possible outcomes. So we say this is what should happen or what's predicted to happen. Experimental probability, on the other hand, is the ratio of the number of positive outcomes to the total number of events or trials in the probability experiment. So this is what does happen when we actually test it out. So in our last vocabulary word that we're going to look at is a complement, and the events of an outcome happening and the same outcome not happening. Now the sum of complementary events is 1. So an example would be if they're asked us to find the probability of heads when flipping a coin. The complement would be the probability of not heads or the probability of getting tails. So the probability of getting heads we know is 1/2 or 0.5. And the probability of getting tails is also 1/2 or 0.5. And we know that 0.5 and 0.5 is 1. And 1 represents all of the events that have happened. So that's what complement is. And we'll have one example that has us finding a complement. So let's look at our first example. We're thinking just about flipping a coin. And we want the theoretical probability of getting heads when we flip this coin. So if we think about it, the coin has 2 sides, and one of those sides is heads. So we have a 1 in 2 chance, or 0.5, or 50%. Okay, now let's think about an actual experiment. If we toss our coin 10 times and it lands on heads 3 times, what is the experimental probability of getting heads? Okay, so we think about how many total times did we toss our coin? That's 10. And how many times did it land on heads? 3. Okay, so 3 out of 10 is 0.3 or 30%. So we predicted the coin to land on heads 50% of the time based on what should happen of the coin having 2 sides. But when we ran the experiment, we actually got that it landed on heads 30% of the time. So while theoretical probability is good for predicting, it won't always match what actually happens. Okay, our next example. We're thinking about rolling a standard die, 6-sided. The theoretical probability of rolling not 5. Okay, well, we know the probability of rolling a 5 is 1 out of 6. The probability of rolling not 5, well, everything else on the dice is not a 5. So there's 5 out of 6 sides that are not the 5, and this would give us 0.83 repeating, or we would say 83%. So we would expect 83% of the time we would roll not a 5. Let's look at an experimental. If a die is rolled 25 times and it lands on 5 10 times, what is the experimental probability of rolling not 5? So again, let's start with the probability of rolling a 5. Okay, out of our 25 rolls, 10 of them were that 5. But we want to know the probability of not 5. Okay, so we want to know if 10 of the 25 were not 5, how many were, if 10 of the 25 were landing on 5? How many were not 5? How many were those other numbers? Remember that complements add up to one whole. So we have 10 out of 25. We need to get to the whole, 25 total rows. Well, if I add 15 to 10, that gives me 25, and we know that 25 out of 25 equals one whole. So the probability of rolling not a 5 is 15 out of 25, which we're going to turn into our decimal. So 15 divided by 25 is 0.6 or 60%. So we predicted to roll any of the other numbers but 5 83% of the time. But when we ran the experiment, we only got 60% of the time. But we do see that this had a higher number of trials, and it is closer to our predicted outcome. And you would expect that to happen. Generally speaking, the more trials you run, the closer you get to your theoretical probability. Thank you for joining me in this Math with Miss V video. I look forward to seeing you in the future.